Okay. The rest of chapter 7. Page 1. So suppose you have this integral. You have a region, you have a region bounded by curve y equals to inverse tangent of x, y equals to 0, x equals to 1, and it's rotated about y-axis. Question says, find the volume of the solid. Very well. Remember that to find the volume of the solid rotated about y-axis, we have a nice formula. V is equal to 2 pi x, so we'll write this inside the radical, and f of x dx. So in this case, your v is equal to the integral 2 pi x. Your f of x is inverse tangent of x dx. So of course your x ranges between 0 to 1. Your goal is to find this integral. 2 pi is just a constant. You can copy down the constant in front of your integral. 2 pi integral 0 to 1 x times inverse tangent of x dx. So when it comes to a multiplication of x and a trig function, the best method is using integration by parts. Integration by parts. So let us for our little table. U, dv, du, and dv. Guys, note that if you take dv to be the inverse tangent, then you need to take the integral of inverse tangent, and you have no idea how to take that integral. So for that reason, you're going to take u to be inverse tangent and take the derivative of inverse tangent, which is 1 over 1 plus x squared. We already know how to take the derivative. So this is inverse tangent of x, and dv is x dx. So the derivative of inverse tangent is 1 over 1 plus x squared dx, and the integral of x is a half x squared. So v for the volume is equal to 2 pi uv, a half x squared inverse tangent, okay, and it is ranges between 0 to 1 by x minus the integral v du. Perfect. I have a half x squared times 1 over 1 plus x squared dx, 0 to 1. Very good. So if I write x squared on my numerator, as you can see, you have the exact same degree. You can either do long division, or you can add and subtract 1 to create the exact same expression on your numerator. So v is equal to 2 pi, a half x squared inverse tangent of x ranges between 0 to 1 minus a half the integral 0 to 1. I'm going to add and subtract 1, or again you can do the long division, you get the exact same result. Divided by 1 plus x squared dx. This is equal to 2 pi, a half x squared inverse tangent of x, 0 to 1, minus a half integral 0 to 1. you do the division between these two, you get 1 minus 1 over 1 plus x squared dx, which is super easy to handle. This is equal to 2 pi times a half x squared inverse tangent of x, 0 to 1, minus a half. The integral is x minus the integral of 1 over 1 plus x squared is inverse tangent. So tangent inverse of x, and your x ranges between 0 to 1. So let's see, I need a little bit of space to put everything inside the bracket. Minus a half x minus inverse tangent of x, 0 to 1, all inside the bracket. So now you can plug in 1, you can plug in 0, you get 2 pi a half. So don't worry about 0, because here you have 0 times tangent inverse, it is going to be 0. So just plug in 1, you get a half times 1 times the inverse tangent of 1 is pi over 4 minus, here you have a half. Again, if you plug in 0, the outcome is 0, just worry about 1. 1 minus pi over 4. So this pi is equal to, let me write it here for you, 2 pi. You get pi over 8 minus a half plus pi over 8. Pi over 8 plus pi over 8, 2 pi over 8, or pi over 4. If you distribute 2 pi, you get 2 pi over 4, pi squared over 2 minus okay. Suppose you want to take this integral. You have integral of x cubed times sine x. Sine x dx. Very well. So when you have x to the n times a trig function, we use integration by parts. So let us form a little table here. U dv, du dv. Okay, du and v. So u is x cubed, dv is sine dx. So du, the derivative of x cubed is 3x squared dx, and v, the integral of sine, is minus cosine x. So this I can be written as uv minus x cubed cosine x minus the integral v du, 3x squared minus cos cosine x dx. So you can take this 3 and write it in front of the integral. Now you have to apply integration by parts one more time. So here you have x squared cosine x, integration by parts. U dv, du, and your u is x squared. Remember that you started from x cubed, exponent was 3. Now you get a lower exponent, which is 2. So we are on the right path. X squared, and dv is cosine x dx. So du is 2x dx, and your v is sine x. Okay, so we have to copy down the first expression that we have here. This is minus x cubed cosine x plus 3 times uv x squared sine x minus integral v du 2x sine x dx. Okay, here you have to apply integration by parts one more time to get rid of this 2x times sine x. So as usual, we can write 2 as the coefficient outside the integral. So we're going to get 2 integral. For this guy, again, we're going to apply integration by parts. U, dv, du, and v. U is x, dv is sine x, du is dx, very well, and my v is minus cosine x. So I have this. Perfect. So I have negative x cubed cosine x plus 3 bracket x squared sine x minus 2, another bracket uv negative x cosine x minus integral v du plus cosine x dx. Perfect. So we get to an integral that we already know how to take the integral, which is integral of cosine. So this is equal to minus x cubed cosine x plus 3 bracket x squared sine x minus 2 bracket minus x cosine x, and the integral of cosine is nothing but sine. And 2 brackets plus constant of integration. Now we can distribute negative 2, then we can distribute 3. If we have anything to combine, we can combine those terms. So negative x cubed cosine x plus 3 x squared sine x minus 6 bracket minus x cosine x plus sine x plus c. So you have negative x cubed cosine x plus 3x squared sine x plus 6x cosine x minus 6 sine x plus constant of integration.